is 30. That is what they give us. So this times the empirical formula is equals to the molecular formula. That's what we're looking for. So this is the formula. Whatever you have as your empirical formula, multiply that by an unknown n. That is equals to what the relative molecular mass which they're giving to you, which will give us the molecular formula. So we find our n. Whatsoever we have becomes our answer. So carbon here is 12. Plus hydrogen here is 1 times 3 is 3. N is equals to 30. So this becomes 15n is equals to 30. Divide both sides by 15 by 15. So n is equals to 2. So in this case, this will cancel this. 30 divided by 15 is 2. N is equals to 2. So if n is equals to 2, it therefore means n is equals to 2. It therefore means CH3 open bracket 2. 2 expand base, we have C2H6. And that is ethane. This becomes our ethane. So we are going to proceed further and solve more. Let's take another question. A compound contains 4 grams of hydrogen. So element given. Element given. Okay, sorry, let me go there. A compound contains 4 grams of hydrogen. Okay, and 64 grams of oxygen. Okay, it's hydrogen and oxygen this time around. Hydrogen and oxygen. 4 grams given. Where is it? A compound contains 4 grams of hydrogen, 64 of oxygen. Here is 64 grams of oxygen. So this time around, it is the mass they have given to us. So we're not going to start with, how do you call it, the percentage composition. We divide by the atomic mass, blah, 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 we'll move on. So now we proceed. Divide by the lowest here, the, how do you call it, the atomic mass of this is 1. That of oxygen is 16. So this is 4. 64 divided by 16. 64 divided by 16 is 4. Okay. So we have 4 here. 4. We divide by the smallest, so that gives us 1:1. So I now have hydrogen 1, oxygen is 1. Open bracket, N is equals to the relative molecular mass. Now, what is the relative molecular mass? Blah 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 by mass. Determine the empirical formula. This is the empirical formula, which is HO. If its relative molecular mass is 76, okay, determine its molecular formula. So now we want to get the molecular formula, which is, this is equals to 76. So, hydrogen here is 1 plus 16. N is equals to 76. This is 17N is equals to 76. Divide both sides by 17. N is equals to 76 divided by 17 is 4.5, which is approximately 6. What do we call that? Let me read it again. A compound contains 4 grams of hydrogen, 64 of oxygen. If its relative molecular mass is 34. Sorry, relative molecular mass is 34. That's a mistake there. Sorry. 34. 34. So when I divide both sides by 17, 34 divided by 17 34 divided by 17 is equals to 2. So my N here is 2. So I have now hydrogen and oxygen, open bracket 2 outside. So this is H2O2. That is a hydrogen peroxide. Okay. Excuse me. Let's take another question, number 6. An uncommon oxide of nitrogen contains 63.2% of oxygen by mass. Okay, let's go there. Element given. We say an uncommon oxide of nitrogen contains this of oxygen. Oxygen, oxygen, oxygen. Now, let me break it down. They say an uncommon oxide of nitrogen, but they give us the percentage of oxygen to be 63.2. We should know that it contains nitrogen, even when they did not give us, okay? So we can now reposition our nitrogen, then oxygen. We check the percentage, 63.2. So nitrogen should come first. Oxygen is 63.2. Now, 100 minus 63.2 minus 63.2 will give us 36.8. 36.8. So that is it. So that is for nitrogen. And we divide by their relative molecular masses, which is here is 14, here is 16. And when we do that, 36.8 divided by 14 is 2.63. Now here 63.2, 63.2 divided by 16, 3.95. 3.95. Now let me read the question one more time. We say an uncommon oxide of nitrogen contains 63.2% of oxygen by mass. A, determine the empirical formula. So that's what we want to do. And then after that, B, if its relative molecular mass is 76, determine its molecular formula. Okay, now let us go. The empirical formula first. Now, from the empirical formula, this is what we have divided by the smallest, which is 2.63. 2.63. And this is 1, and this is 3.95 divided by 2.63. That gives us 1.5. 1.5. Remember, we divide by 2. Multiply by 2. This becomes 2:3. So I now have nitrogen here is 2. Oxygen here is 3. So that is it. That's my empirical formula. B. They say I should find a molecular formula if the molecular mass is 76. So I can easily say this N is equal to 76. Okay, nitrogen is 14. 14 times 2. 14 times 2 plus 16 times 3. Okay. Yeah. This is equal to 76. N. Sorry, my N is outside. 76. 14 times 2 is 28. 28 plus 16 times 3 is 48. N is equals to 76. So 48 plus 28, 76. N is equals to 76. So this is 1. Okay, divide both sides by, okay, let me open it. 76N is equals to 76. Divide both sides by 76. By 76. Cancel this. N is equals to 1. Therefore, the molecular formula is also N2O3 because 1 times the variables inside will not change, will still give us the same thing. So the molecular formula and the empirical formula are the same. So let's proceed and take more questions. Okay, a compound contains 7.2 grams of nitrogen and 1 gram of hydrogen. So we have nitrogen and hydrogen. Element present, nitrogen and hydrogen. Okay, a compound contains 7.2 grams of nitrogen. So nitrogen is 7.2. 2 grams of nitrogen and 1 gram of hydrogen. Yes, 1.0. That's the percentage, the mass of hydrogen. If the relative molecular mass of the compound is 32, determine its molecular formula. So, for us to go there, we have to first of all divide by, this is our protein, this is our 1. So I have my 7.2 divided by 14, 0.514. 0.514. And this is 1. Divide both sides by the lowest, which is 0.514. 0.514. Here gives me 1. 1 divided by 0.514 is 1.9, approximately 2. So now I have my relative molecular mass is nitrogen, empirical formula is 1 and hydrogen is 2. So this, I want to get the molecular formula N is equals to my relative molecular mass. Did I give? They say is 32. So this is equals to 32. So nitrogen here is 14 plus 2. N is equals to 32. 16N is equals to 32. You divide both sides by 16. This cancels. My N is equals to 32 divided by 16, 2. Therefore, my relative molecular mass, my molecular formula become N H2, open bracket, 2 outside. So this becomes N2H4. So this is what I have. If this is my molecular formula, it equals to N, and my N is 2, I multiply through by 2, I have N2H4. Okay, let's move on. Take another question. A compound of empirical formula XY. Okay, they've given us empirical formula XY, has a molar mass of 26. Calculate the molecular formula. If X is 12 and Y is 1. So element given is XY. If X is 12 and Y is 1. And so they've given us their relative molecular mass, yes. We divide by the lowest, which is 12 and 1. Yes, it still gives us the same thing. So this is equals to the easiest way, we now put it in bracket. Our XY is equals to the relative molecular mass is 26. Here is 26. If X here, N is 26. If X is 12, plus 1, N is equals to 26. This is 13. N is equals to 26. And divide both sides by 13. N is equals to 2. Therefore, we have X2 Yeah. Y2. Because x is 2. From here, it was xy, and I have my n to be 2, so I expand. 2 times x is x2, 2 times y is this. Okay, let's take a couple more questions before we call it off. Vitamin C, which may or may not be effective in preventing cold, is an organic compound containing carbon, hydrogen, and oxygen. So let's write the element present. We say it contains carbon, hydrogen, and oxygen. Okay. Analysis of a carefully purified sample gives carbon is 40.9%. Okay. Hydrogen is 4.58%. 4.58%. And oxygen is 54.5%. 54.5%. So this is our oxygen. Okay. From another experiment, the 1 molar mass of vitamin C was found to be 180. The relative molecular mass is found to be 180. From this data, determine the empirical formula of vitamin C. So that is 180. We will get there, but let's finish here first. So this divided by 12, divided by 1, and this is by 16. So I have my 40.9 divided by 12 is 3.41. 3.41. This is 4.58. Divided by 1 is the same. And 54.5 divided by 16. 3.41. 3.41. The lowest is, we divide is 3.41. 3.41. 3.41. So this is 1. 4.58 divided by 3.41 is equals to 1.3. 1.3. And this is 1. We say whenever we have this, you multiply through by 3. So this becomes 1.3 times 3 is 4 and 3. So now I have my carbon here is 3, hydrogen is 4, and oxygen is 3. So that's my empirical formula. That's not all. They say if the relative molecular mass of vitamin C is 180, from this data we should determine also the molecular formula. So base N is equals to 180. Let me finish it inside. Carbon is 12 times 3 plus hydrogen is 1 times 4 plus oxygen is 16 times 3. N is equals to 180. Okay? So first, 12 times 3 is 36. 16 times 3, 48 plus 36. Equals to this plus 4, 88. This is equal to 180. So I have 88N is equal to 180. Divide both sides by 88 by 88. N is equal to 180 divided by 88 is 2. So therefore the molecular formula becomes C3H4O3. 2 outside becomes C6H8O6. This is the molecular formula. Let's take another one. Vitamin A, an essential growth factor found in butter, egg, fat, and cod liver oil, analyzes as follows: 83.86% by mass of carbon, 10.56% hydrogen, and 5.58% oxygen. What is the simplest formula? What is the empirical formula? So we say vitamin A contains carbon, hydrogen, and oxygen. So this is my carbon, my hydrogen, and my oxygen. Let's check the percentage. The first one being cod liver oil analyzes as follows: 83.86%. 83.86% of carbon by mass of carbon, 10.58 hydrogen, 10.58 hydrogen, and the last 5.58 oxygen. 5.58 oxygen. Divide by the relative molecular mass, which is 12, 1, and 16. So 83.86 divided by 12, that is 6.99. 6.99. 10.58 divided by 1 remain the same. 5.58 divided by 16. 0.3. 0.349 divided by the lowest, which is 0.349, 0.349, 0.349. So this is 1. 10.58, 10.58 divided by 0.349 is 30. Okay, and here 6.99 divided by 0.349. 349. Okay, it's 20. Okay, so first we are divided by the relative molecular mass. We have this, we divide by the lowest, and we have this. So we say carbon, in this sense, is 20, hydrogen is 30, and oxygen is 1. So therefore C20, H30, O. This is our simplest word formula. Let's take maybe one more. An organic compound is made up of 0. Hydrogen and oxygen. Calculate the empirical formula of the compound. It's made up of 0.72 grams of carbon. Okay, let's come back to the element given. I take this out. Okay, an organic compound is made up of 0.72 grams of carbon. 0.72 grams of carbon. 0.16 of hydrogen. 0.16 grams of hydrogen. And 0.32 grams of oxygen. 0.32 grams of oxygen. Okay, calculate the empirical formula of the compound. So divide by the lowest, by the atomic masses. This is 12, this is 1, and this is 16. So 0.72, 72 divided by 12 is 0.06, 0.16, 0.32 divided by 16 is 0.02. Okay, we divide by the lowest, 0.02, 0.02, 0.02, 0.02. So here is 1 already. 0.16 divided by 0.02. 8. Now 0.06 divided by 0.02 is 3. So we have 3 carbon, 8 hydrogen, and 1 oxygen. So that's what we get. So we will take one more. Calculate the molecular formula of a compound with the following percentages by composition: sodium, carbon, and oxygen. Water of crystallization. Okay, I think we saw something like this. Let's see if we can get something else. 30% of nitrogen, calculate the empirical formula of the oxide. An oxide of nitrogen contains 30.4% of nitrogen. Now, in the element given, an oxide of nitrogen, so we'll be having nitrogen and oxygen. You see, an oxide of nitrogen contains 30.4% of nitrogen. 30.4% of nitrogen. What is it? Calculate the empirical formula of the oxide. So an oxide means is nitrogen and oxygen, we know that, and the percentage given is that of nitrogen, which is 30.4, and that oxide is supposed to give us 100%, which means 100 minus this, give us the other one, 60, whatever it is. 100 minus 30.4, 69.6, 69.6. So divide by the relative molecular mass, which is 14, 16. So 30.4 divided by 14, that is 2.17. Yes, 69.6 divided by 16, 4.35. 35 divided by the lowest, which is 2.17. So when we check that, this is 1, of course, and this is 4.35 divided by 2.17 is 2. So we have 1 nitrogen, 2 oxygen. So this is our relative molecular mass. So far, we've seen that in empirical molecular formula, that the empirical formula gives us the simplest form in the ratio form of the element present in the compound, while molecular formula we say is empirical formula times n is equals to the relative molecular mass, which is the procedure principle, which we can use to get what we want. So we've illustrated many times, like for example, they give you the percentage of carbon. Meanwhile, they say it's hydrocarbon. Carbon only is given, and oxygen is not given. Or hydrogen is not given, for example. And we know hydrocarbon contains carbon and hydrogen, and they've given you that of carbon, that of hydrogen isn't given. We should know that the leftover percentage, if 30 is that of carbon, 70 will be that of hydrogen, even if it is not given, because we understand that it's hydrocarbon. And they've also seen certain questions like an oxide of this, an oxide of that. That oxide, if it is carbon oxide, you know probably that you should have carbon and oxygen, and they are giving you only oxygen without carbon and its percentage. So the percentage of oxygen given, subtract that from 100, you get the other one of carbon. The same thing goes to nitrogen oxide of any sort. They give you that of only nitrogen without oxygen. You should also know that you have to do the same principle which we have been doing in the previous. So in empirical molecular formula, it helps us to know the easiest way in which we'll be able to get our relative molecular masses being applied to the empirical formula in order for us to get our molecular formula. And we also understand that we must have our empirical formula first before getting our molecular formula. And if we follow the principles, the procedure perfectly, we don't have any issue, especially in the aspect where we have a 1.5. You don't leave it like that. You have to multiply all through by 2, or we have 1.33 or something. You multiply that by 3, and that on and on. With this fervent knowledge, I strongly believe that you're not going to have any challenge or challenges in the course of solving questions that have to do with empirical and relative molecular mass. So thank you and have a wonderful day.